Good morning, guys, or whatever time you're watching this. Welcome back. Today we're going to look at solving exponentials and logs. This is section 3.4 in the textbook. So, we have a few basic rules to follow here. If we have something that starts out as a log, we will want to condense that if possible. Sometimes this step does not have to be done. Other times it will be very helpful to condense. This way you only have one log to undo. Then we are going to isolate the log or exponential on one side. Once we had that isolated, we will solve. Use exponentials to undo logs. Use logs to undo exponentials. So we are going to start with some very basic examples here. So for this, we are going to start example 1 is going to have two ways. It's really just going to be focused on this because everything's already going to be isolated. Example 1 has two parts. Part A says log base 8 of x is equal to 1/3. And B says 5 to the x is equal to 0.04. So with these, this is going to be a matter of utilizing this step in orange and going from there. So there's only one log. It's already condensed. The log is already isolated on this side, so we're good. So we want to solve. So essentially what I'm going to do is make both of these an exponential with a base of 8 since it is a logarithm. The base of 8 for the exponential and the logarithm here conveniently cancel out with each other. And that will just leave me with x equals 8 to the 1/3 power. Now, some of you may realize what the cube root of x is right away. But in case you're having trouble with that, again, I'll show you how we can utilize calculator to do that. So all I'm going to do is type it in. Let me get this into better projector mode. So when I type this in, this will be 8, then due to the power. Now since it's a fractional power, I'm going to want to put it in parentheses, 1/3. Or it's already giving me the answer of 2, which makes sense. 2 cubed is 8. So the cube root of 8 is 2. So there is that. So this one ended up just being 2. Now the next one with it being decimal, you might not recognize it so easily, but this is the same sort of idea. So here with this, since this is an exponential, I want to use logs to undo exponentials. So I'm going to rewrite this as log base 5 of 5 to the x is equal to log base 5 of 0.04. So here with these, the log base 5 and that base of 5 and that exponent conveniently cancel. So that just leaves me with x is equal to log base 5 of 0.04. Now this one's actually going to turn out to be a very nice number, but you might not see it off the top of your head because that's not a very common decimal. So again, I'm going to utilize my calculator. I'm going to go function, go over to miscellaneous. I want to choose log base A so I can make that base 5. So the base of the log is 5. the number inside is 0.04, and it gives me -2. So here with this, as a fraction, this be 1/25th, but again, that's not a very common fraction you see, so getting that in your head is definitely a little more challenging. But we've got these calculators, and we've been working with these calculators, so it shouldn't be too big of a deal. So, that is example number 1. That's the general basis of this. So, here with this, we have another problem to do. This one will be a little more complex looking, mainly because we couldn't solve that, the one we're about to see in our head. I'm going to call this example C. So it says 10 to the x is equal to 90. So I'm going to use the exact same idea I did here. My only problem is I have no clue what power 10 will have to go to get 90. I know 10 squared is 100. 10 to the first is 10. So it should be somewhere between 1 and 2. But what exactly that is, we're going to have to utilize a calculator. So I want to take the log of both sides. Now I'm just going to call this, or I'll write as log base 10. You don't have to write base 10 for a log, remember? That's our default base. But if you want to write it, it's not going to be wrong. 10 to the x, and then do log base 10 for this side as well. So, with this, that part conveniently cancels, leaving me with just x equals, and now we're just going to have to use the calculator to do this problem. So, again, just type it in. You can go functions, log with a base, put my base as 10, and the number inside as 90. So again, I said I want 4 decimal places, 1 decimal, so that would be 1.9590. If you wanted to drop the 0, I'd be okay with that, because it is ending in a 0. Oh, wait, that was 91, not 90, sorry. If I change that to 90, it changes that to 1.9542. So, again, going to go 4 decimal places on it to 1.9542. And that's it. Now, we are going to get into some examples that will require us to condense and then isolate before doing some solving. But those are going to go back to skills that, well, condensing we learned in the last section, and getting the exponential isolated or the log isolated are going to go back to simple algebra skills that you've learned in previous classes. So let's look at example number 2. In example number 2, what we're going to do is, once we have the ability to take an ln, we are going to do that and go from there. So it's going to start out with the brighter red marker. As e to the x minus 2 minus 7 is equal to 59. And we're going to round to 4 decimal places, so the example in the notes I gave you rounded it to 3. I just want a little more accuracy. So first thing we need to do is isolate here. So I'm going to start by adding 7 to both sides. When I add 7 to both sides, that gives me e to the x minus 2. That's what I'm trying to isolate right now, is equal to 66. So, now that I have an e by itself, I'm where I want to be to start solving. So I want to use a logarithm to undo the base, or the exponential. Since this has a base of e, I want to take the ln of both sides. So the ln and the e conveniently cancel out to give me x minus 2 is equal to, now I'm just going to use a calculator here. Let's put it in the calculator. ln of 66. So remember, when something has a base of e, you always want to use natural log. So I'm going to go to functions, go to miscellaneous, and ln is right there. ln of 66. Now again, there's no way we're going to know this number off the top of our head. We have to utilize the calculator. But we'll get 4.189, and that 6 will get rounded up to a 7. So let's write that down. 4.1897. And then, hey, x isn't all the way by itself. This is easy to finish solving now. Since it's a minus 2, let's finish solving by adding 2. So when I add 2 to that, that will give me 6.1897. So this example, we did have to isolate first. So we're trying to get either the exponential or the logarithmic piece by itself before we can take the ln of things. Because if we tried to take the ln of things here, that 7 would get trapped inside of it, and there's really not much we can do from there. So the next example we are going to see. This one is a little more unique of an example, and actually not too bad of an example at all. This is going to slightly break from the steps up here, and I'll explain why. So example 3. This says the log base 6 of 4x minus 7 is equal to the log base 6 of x minus 8. So here, notice how it's both the same things inside the log. Since it's the same things inside the same, they're both inside the same log base 6. I know you had to bring them over to the same side or anything. What I can say is, hey, 4x minus 7 is equal to 8 minus x. Because I'm taking the log with the same base, I'm allowed to say, hey, set what's inside equal to each other. So let's see, let's add x to both sides, giving me 5x minus 7 equals 8. Add 7 to both sides, and we get 5x equals 15. Divide by 5 to get an answer of x equals 3. So with that, because they both say log base 6, essentially what I did was use exponentials to undo the logs. Take both as 6 to that. 6 to that. But since they cancel out, I kind of did it a little shortcutted. Because, hey, we're doing the same thing to both sides here. I'm just getting rid of that. let's take a look at one last example. This one will have an ln in it, so we're going to have to undo it. So let's take a look at this is example 4. Though it does say example 3 in your notes, I add example 3 as this. That is still in the notes associated with this. Just goes slightly out of number to what it says on the paper. So, here with this, sorry, lost the example, there we go. This one says we have 4 times the ln of 5 to the x is equal to 28. Now here with this, I could condense this and put that as a power of 4. But I'm sure a lot of you don't feel like taking fourth roots. It's going to be easier just to isolate this by dividing by 4. So if I notice here, 28 is easily divisible by 4. So hey, life's easy there. The ln of 5x is now equal to 7. So now my ln is isolated. Now remember, the base of ln is e. So I'm going to rewrite this as e to the ln of 5x is equal to e to the 7th. So that's using this step here to use exponentials to undo logs. Since this is a natural log, I'm changing this into an exponential form. So that gives me here the e and the ln cancel out, leaving me with just 5x is equal to, let's see what e to the 7th is. I'm going to have to utilize a calculator on that. That one, my powers of e, do not know those off the top of my head. So remember, we can go to the keyboard and just use the letter e. And then if I go back, go power to the 7th. And I get, again, go 4 decimal places on it, 1,096.633, and that 1 would get rounded up to a 2. So I'm just going to write that down. So 1,096.6332. Now, x is not all the way by itself right now. Let's divide both sides by 5 to get it there. And then we'll get x is equal to, again, I'm just going to take that answer, e to the 7th. And what I'm going to do in the calculator is just hit right behind it, divided by 5. And that gives me 219.3266. So 219.3266. And that's it. So with this, sometimes you will get problems where you have to condense. We didn't see a situation where we necessarily had to do that. I don't think one pops up on your homework either, but if you see more than one log, if they're on opposite sides, you could do that trick like I did in example 3. But if you see them on the same side, hey, if they're added, bring what's inside together as multiplication, so you only have one log. If they're subtracted, bring them together as division, so again, you only have one log. So have a good one, and I hope you found this video helpful.